Good morning, students. Let us start again Euclid division lemma from beginning. As I told you earlier, for given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r. And you always know r is always greater than equal to 0 and less than b. This is nothing but a simple division lemma as you studied earlier, and that is dividend equal to divisor into quotient plus remainder. You can also write like this, and here a is your dividend, and b is your divisor, q is your quotient, and r is your remainder. This division lemma is given by Euclid, and first of all I want to tell you what is lemma. And lemma is nothing but a proven statement. It is a proven statement that is used to prove another statement. It is proven statement that is used to prove another statements. So let us take an example. We are having two numbers. For example, it is 25 and 8. So if I divide 25 by 8, then we have 3 as your quotient, and it will go up to 24, and we have remainder as well. So see, this is a simple division. By Euclid division lemma, we can write this one as, since 25, you will take this one as a, and you will take this one as q, and 8 is your b, and r is your now 1. So we will write 25 as your b into q, that is 8 into 3, plus remainder, that is r 1. So we'll use this concept to find out SCF of two numbers, and that this is a simple step, and we'll use this in Euclid division algorithm. Euclid division algorithm is nothing but it is a technique to compute the highest common factor, that is SCF, of two given positive integers. You can recall that HCF of two positive integers is the largest positive integer that divides both the numbers. So how we'll find the HCF of two numbers by Euclid division algorithm? So I want to write the algorithm first. Note it down, everyone. We have step one. You have to apply for the two given positive integers. You have to apply Euclid division lemma. We are taking two numbers as your a and b. Let us take a is greater than b. I can write here also a is greater than b. So first of all we have to check which number is greater, and the number which one is that greater, that is your dividend, and that is which one is less, that is your divisor. So what you will do, you will first apply the step 1. You will apply the Euclid division lemma, and if you have remainder 0 in the second step, then your divisor is your SCF. And if your remainder is not equal to 0, then you will apply Euclid division lemma to your divisor and your remainder. Obviously the remainder will be less than the divisor, so you will apply this one again, and you will continue this process till your remainder is 0. And remember always one thing, your divisor will be your SCF when you have remainder as 0. Let us take an example for finding out the SCF of two numbers. Let we have example that we have two numbers, and the numbers are 135 and 225. That is the first question of exercise. So first of all, we check that which of these two number is greater. So we have 225 is greater than 135. So you will take 225 as your dividend and 125 as your divisor. Now we'll take 225 as your dividend. So you will apply Euclid division algorithm here. 2 to 5 will be equal to your 135 into to 1, and plus you will have 90 as your remainder. You will have this is dividend and 135 is your divisor. 1 is your quotient and 90 is your remainder. Remainder is always less than your divisor. So here your remainder r is not equal to 0, so you will apply Euclid division lemma again. So now you will take 135, that is your divisor, as your dividend. You will take 135 here. Now you will take your remainder as your divisor, so you will write 90, and again it will go up with 1. If I multiply this by 2, then we have 180, that is larger than 135, so it will go up by 1, and you have remainder as 45. So you can separately divide this one, and you can see if you divide 135 by 90, it go with 1, and you have remainder as 45. Okay, you can make this as in your rough part. And again, now you will take this 90 as your dividend and 45 as your divisor, and you can see it will go with 2, and now remainder is your 0. Now if your remainder is 0, then your SCF is 45. Always remember, divisor will be your SCF. Okay, sometimes the student write the question there, that is wrong. You can try some questions using this one, and for example, that is for your practice. You can have 196 and 38220, that is the question of NCERT. And also you can have 867 and 255. So next topic is how to find SCF of three numbers using Euclid division lemma. To find out SCF of three numbers using Euclid division lemma, let us take an example. We have numbers, for example, you have 42, 56, and you have third number is 126. Okay, for what we will do, we will first find out SCF of two numbers using Euclid division, and then the SCF of the two numbers, it will go with the third number. We'll apply the Euclid division algorithm with the third number. So we are taking 42 and 56 first of all. Let we have in first part we have 42 and 56. As we know, 56 is greater than 42. So 56 is your dividend, and you will write 56 as 42 into 1, and your remainder will be 14 there. So can you see remainder is not equal to 0? So now this is your divisor. It will become now dividend, and this remainder will become your divisor, and it will go with 3, and now remainder is 0. Here we have r not equal to 0, and here we have r equal to 0. When r is 0, therefore your SCF of 42 and 56 is 14. Now you will take 14 and 126 as two numbers, and you will apply Euclid division algorithm in these two numbers. So obviously we have 126 is greater than 14. So taking 126 as your dividend, you will write this as 14 into 9 plus 0. In the first step you will get 0 here. So 14 is also the divisor of 126. So you can say SCF of 42, 56 and 126 is 14. That is your answer. Hopefully you understood this one, and you have some questions as your homework. Find SCF of, I am giving you three numbers, 39, 52, 114, and this one the first question, and second one is you can write 38 and you have 114 and 173. So take these two numbers and try to solve. We'll meet in next part.